Hello and welcome back to another tutorial where today I'm going to show you how we can do some coding to create a set of dice that have a very peculiar quality. But our main focus today is to work out some probabilities of when we roll dice and if they are higher than the dice next to them. So this is leading on from the jackpot tutorials that I've done in a previous tutorial where you might want to look back on that, because if you've got your three dice, it's going to make it really easy to have a go at this. We can see how we've got probability of A beating B and B beating C, and I'll talk a bit more about that later on in the video. All right, let's get coding. Okay, first we're going to start at this point where we have three dice, and the three dice all have the code where when you click the green flag, they will roll to a random number. And I just want to show you, first of all, what we can do with this at this stage. Now, if you remember, when we've created these dice, and I think I'm going to change them now to say dice 1, dice 2, and dice 3, because I think that's going to help with the code later on. So I'm just renaming them something a bit more straightforward. And when I click on the costumes, you may remember we've got each costume is the number 1, 2, 3, 4, 5, and 6. So it's important that they're all in order 1 to 6. All right, so going back to Scratch Cat, you can see I've already got some blocks here, and it says when the green flag is clicked, I've got an if then, and I'm just going to say dice 1. Now, actually, I don't want to do it when the green flag is clicked just yet. I'll show you why in a minute. But I've got this one here, which this block is quite hard to find. It's in the blue section, and it's at the bottom, and at the bottom it actually says backdrop number of stage. But when we bring that out and we change it, we get all of the different sprites, and we can choose dice 1, and then we can choose the costume number. So that's how we get that block here. And all I'm doing is actually comparing the costume number of dice 1 to the costume number of dice 2. So here, the costume number of dice 1 is 2. The costume number of dice 2 is 1. Confusing numbers. When I click on here, it says it's true because 2 is bigger than 1. Let's do another roll. This time we've got a 1 and a 2. So when we click on it this time, it says false because 1 is smaller than 2. Try it one more time. Now they're equal. And so that's false because this one is not bigger than that one. Right, now if I drop it into here, I don't want to do it when the green flag is clicked because they haven't finished rolling yet. So what I need to do is I need to broadcast something. So I'm going to create a broadcast, and I'm going to broadcast spin. So when I click the green flag, it's going to broadcast spin, and then on each one of my dice, I'm going to change it so that it spins. So I'm just going to update that now. Okay, so now it says when I receive spin, that's when they're going to spin. I'm also going to change it so that it doesn't repeat a random amount. I want it just to repeat this. I just want it to switch a costume. So you can see now that when we click on it, we get the different numbers. Now, it's not as dynamic as it was before, but that allows us to do more research into which dice is winning more than the others. So now when I receive the spin, it spins them all, at which point we can then add this in. So hopefully now we can see 2 is not bigger than 2. Now 3 is bigger than 2. It still didn't work. So I think we're going to have to add in a wait 0.1 second before we check. There we go. So just that delay there allows Scratch to figure out the numbers and then decide if dice 1 is bigger or not. Dice 1's winning quite a few times there. Okay, so just zoom in so you can see that. Okay, now it gets a little bit complicated, but what we want to do is we want to see how many times this dice beats this dice, and how many times this dice beats this dice, and how many times this dice beats that dice. So we're going to have to create some variables, and we're going to have to create quite a lot. There are 6 things that could happen. This one could beat this one, and this one could beat this one. This one could beat that one or that one, and the green one could beat the red or the purple. So we need 6 different if statements and 6 different variables. So I'm going to get to them. I'm going to call them each one. I'm going to say A beats B, or I'll keep it as numbers. 1 beats 2. Okay, and then I'm going to do another variable which says 1 beats 3. 2 beats 1. 2 beats 3. And finally, 3 beats 1. 3 beats 2. All of them. That's all the different outcomes. That covers everyone winning. I'm not doing like losing as well. That should be quite easy to spot. So what I'm going to do now is I'm going to duplicate basically all of this 6 times to account for each one of these. So this one here is dice 1 beating dice 2. So if dice 1 beats dice 2, we want to change 1 beats 2 by 1, which basically means it gets a point. So we're going to duplicate this. If dice 1 beats dice 3, then we want 1 beats 3. Change it by 1. Move on to number 2. If number 2, oh, now notice this changes, so I need to put it back to costume number of dice 2 beats costume number of dice 3. Just notice that one too. So does 2 beat, let's do 1 first. Does 2 beat 1? Does 2 beat 3? And I'll quickly do the last 2 as well. Okay, so we should have accounted for every single result. And if I move the variables underneath the relative dice, I think I'll swap them around. Now when we press the green flag, so 4 beat 3, so 1 beats 2. 3 didn't beat 6. 6 beat both of them, so you can see they got 2 points. And we can run it again. This time 3 beat both of them, so they got 1 point each. Then this time, this one won both of them. So you see here how it's adding up the scores. Here, this one beat both of them, but then this one also beat that one, so he gets the point too. If there's a tie, like here, neither of them get the points, but they do get a point for beating the green. All right, so we can see here that already we've got a 4, so 2 is beating 3 quite a lot, but it's a small sample size. We need to do lots and lots of rolls. So to do lots and lots of rolls, we're going to repeat the whole thing by using a repeat. And let's repeat it 20 times. You can even change this weight so it's a little bit faster. And let's go. Now you can see here that it's pretty even. And that makes sense. It should be pretty even because they all have the same numbers on. But it's still quite interesting to see which of the dice is the luckiest. So at the moment you can see that 1 has beat them both 2 and 3 exactly the same amount of times, whereas number 3 seems to favour beating number 1 than it does number 2. But we aren't going to stop there. We are going to investigate this even more, just like great mathematicians do. And the way we're going to investigate even more is we're going to change the dice numbers. So we're going to have them not necessarily being 1 to 6, and we're going to see how that works. And the way we're going to do it is we're going to use lists, because I could go into the costumes and I could change it so that it says 2, 2, 2, 2, 2, 6. But then I'd have to change all the costume numbers and the sizes, and then if I wanted to change it again, I would have to put it all back again. Actually, there's a quicker way. If we use a list, and we're going to need 3 lists. Dice 1, dice 2, and dice 3. And then inside these lists, so you can add that here, we're going to put the numbers in. So I'm going to make dice 1 the following. I'm going to make it 3, 3, 3, 3, 3, and 6. So we've got 6 numbers still, but nearly all of them are 3s, except for 1, 6. On the second dice, I'm going to make it 2, 2, 2, and 5, 5, 5. Get rid of number 7. And finally, dice 3. On dice 3, what have I used so far? 2, 3, 5, and 6. So let's use 1 and 4. So I'm just going to put a 1 and all the rest 4s. Okay, there we go. So we've used up all the numbers 1 to 6, but we've spread them out in a very peculiar way. Now, we don't actually need to see the dice anymore for now, so we can untick them. And the last bit of code that we need to change is in the spin, it says switch costume to pick random 1 to 6. Now we need to say switch costume to, and we've got these extra blocks because we've created a list, these kind of orange, burnt orange color. And I'll zoom in so we can see a bit better. Switch costume to item number, pick random 1 to 6. So we can just try that again. And we can see here this purple one should only ever be 3 or 6. So it's getting 3 most of the time. Oh, I did see a 6, and there we got a 6. So that bit of code we need to change on each of the dice. Now we've got to be careful because some of these are very similar. Okay, there we go. Try that out. I'm getting a 3s and 6s, and that's because I've got it as dice 1. There we go. Dice 2. 2, 5, 2, 5, 2, 5. And last one. Okay. So now we can probably create a clear. We need to clear all of the data. This is going to take a while too. We want to set everything to 0. Okay. So when flag clicked, let's set everything to 0. And let's repeat 100 times this time. So we're going to do 100 rolls, and it's going to work out who beats who. So we've done about 100 rolls there, so much quicker than we would have been able to if we'd have had some dice and created them and played it ourselves. And we notice that number 1 beats number 2 more often than not. So 60 out of 100 times, number 1 beats number 2. Then we've got something interesting here because number 2 beats number 3 just slightly most of the time. Okay, so number 2 beats number 3 more often than not. So number 1 beats number 2 beats number 3. Well, then, how peculiar, because number 3 often beats number 1. So they all have a chance of beating each other. And this is called, it's got a very special name. It's called non-transitive. These dice are non-transitive, which basically means they don't follow that idea that if this one's the best, it could generally beat all the others. It actually goes round in a circle, and it's quite hard to come up with dice that have that property. You can even get more than 3, so you can even have a non-transitive dice set of 5, where one would be another, the other one would be another, and then it would go back to the start again. This is like rock, paper, scissors. Rock, paper, scissors is a non-transitive game because rock beats scissors, scissors beat paper, but paper beats rock. And this is kind of a dice version of it. And what's great about this activity is once we've got this set up, well, we can try all sorts of numbers because all we need to do is go into the lists by clicking on variables, untick these, and we can play around with these numbers to try and make our own versions. Now, I've shown you one that I knew definitely was going to work as a non-transitive dice, but I wonder if you can create your own by finding a way that 1 always beats 2, 2 always beats 3, and 3 generally always beats 1. Obviously, that isn't for just 1 or 2 rolls or even 10 rolls. We're talking about rolling over a large amount of time. So basically it has a better chance of beating the other. Have a go at playing this. There's loads of maths to discover in here, loads of good talk about probability. You can simplify it to having smaller numbers. Once you've got this list mechanism, you can even add extra numbers in. You could even have one dice only has 2 numbers, whereas the next dice has 5 numbers. You can be really experimental with it and try out those different probabilities. I hope you enjoyed making it. I think this is a great fun activity. I added a little bit extra when I did mine so that I had some probability that it worked out underneath, which was fairly easy to do. It just counted the rolls and then worked out how many out of those rolls it had won. Thank you so much. I hope you enjoyed this tutorial. There are loads more on maths at btc.com. This is one of our more advanced ones. There's lots of easier maths project ideas too. Okay, I'll see you soon.